It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Welcome to Unacademy and welcome to Unacademy Semester Exams. Parimala, good evening. Kishore, good evening. Soumya Narayan, welcome, good evening. So we are dealing with the control systems quick revision as a part of semester exams chapter 5 today, lecture number 8. Before that, let me tell you about myself. I am sravan Kumar, having 7+ years of teaching experience and mentored more than 5K students for GATE and ESE and cracked GATE. Unacademy, let's crack it. Crack GATE and ESE with India's largest learning platform and get subscription. You can install Unacademy Learning app from Google Play Store and click on this install. And what you get is you get daily live classes, structured courses, live test and quizzes, unlimited access as well. Also guys, please do inform your friends and ask them to join the session. Unit 5 quick revision will be done and previous semester questions will be solved in this. In Iconic subscription, you get personal coach, study tracker, mains question and answer and all the benefits of Plus. And in Plus subscription, you have daily live classes, structured courses, live test and quizzes and unlimited access as well. You can learn from the top educators of the Unacademy, as you can see. And as a part of this subscription, you'll get GATE and ESE batches and year-long courses you have for all the specializations and all the courses. In Plus subscription, you get all the benefits of the Iconic subscription, you get all the benefits of the Plus along with some special benefits, as you can see here: personal coach, personalized test analysis, study planner, preparatory study materials and so on. Also, if you are opting for Plus subscription, suggest you to go for 24 months. You can use my code YSK10 to get the maximum discount for a limited period of time as well. And the one that is best for every student is going for an Iconic subscription for 24 months. You can use my code YSK10 here and you can get discount on this price. And today we are dealing with the control systems chapter 5. So guys, do inform your friends. This is very useful session. We'll be solving some semester exam questions. I'll give you a quick idea of what the chapter 5 of control systems course has. Then we'll discuss some topics. So in unit 5, that is state variable or state space analysis, you have, let's divide this into two parts, part A and part B. I'll discuss what is a state model first. I'll just give you a brief idea of state diagram and state these things. Then, because it is a question and answer session, quick revision, will not be getting into details of this. State diagram, solution of state equation, which is nothing but the ZIR and ZSR, what you call it as. Then you have transfer function. How do you find transfer function from state model? You also have state transition matrix, right? This we'll discuss as a part of part A, and in part B we'll discuss diagonalization, controllability, observability, and some topics on discrete time systems. Discrete time systems, also pole placement method, pole placement by state feedback. This will be in the tomorrow's session. We'll cover up these topics in the tomorrow's session. Controllability, observability. This is controllability and observability, diagonalization. Meghana, good evening. Welcome to Unacademy and Control Systems course. So first I'll give you an introduction of the state model, state diagram, solution of state equation, transfer function of state model, state transition matrix. Then we'll take up some semester questions, questions that are asked in the semester examinations, and let's try to write their answers. So this state space analysis is studied because it has some advantages. The advantages, the major advantages are, it is applicable to MIMO system. Let's write that. It's applicable to MIMO systems. Then applicable to nonlinear and time invariant, or you can say simply time invariant system, and time variant also. Time invariant and time variant systems both, whereas the classical methods are applicable to only LTI systems, linear time invariant systems, but this is applicable to time variant as well as invariant systems. Also it takes into account all initial conditions, right? And because we use matrix algebra, it is easy to understand also. We'll use matrix algebra and design for any, you can design for any input. So this is one question that is asked in your exams also. What are the advantages of state space analysis? So that question will be asked in your exams. So I want everyone to note down these points and write the answers. Now, second, we'll consider a system first. I'll just give you a quick review of everything, then we'll start solving some problems very fast. Let's consider this is a system. MIMO system, let's say, and it has some inputs. We'll call inputs as U1, U2, UM, and has some state variables as x1, x2, and so on, x3, and so on, xn, and has some outputs y1, y2, and so on, yp. So what is state model is? We'll write state model. State model is, you have state equation. In a state model you have a state equation which is x dash is equal to a into x plus b into u. Then you have an output equation these two are combinedly called as state model. So this is a state model, right? Now let's look at the state model. This is x dash is equal to a into x plus b into u, y is equal to c into x plus d into u. Here x is a column matrix. This is x1, x2, x3 and so on. Let's try to write it as x2 and so on. How many number of state variables we have taken? N. So it is xn. So it is n by 1 matrix. So this is a column matrix where x1, x2, x3 are xn are state variables. They are called as the state variables, nothing but the inductor current, capacitor voltage, likewise. Similarly, from this you can write x dash. What is x dash? It is x1 dash, x2 dash and so on xn dash. This is also an n by 1 matrix. Also, this is also called as state matrix or state vector, right? And this is y is equal to, it's a if you take multiple outputs, you can say y1, y2 and so on yp. This is an output matrix or an output vector, right? Similarly, you can also consider u, which is equal to u1, u2, u3 and so on um, which is m by n, m by 1 matrix. This is p by 1 matrix. This matrix is called as the input vector or input matrix, right? So this is what you have basically. So the basic things that you have to remember is x dash is equal to a into x, y is equal to c into x plus d into u, and this is ax plus bu, right? Now you need to draw a state diagram corresponding to this. A state diagram is a graphical representation of a state model. So we have x dash is equal to a into x plus b into u, y is equal to c into x plus d into u. So we have a summation here. So you need, in a state diagram, you need a summing point. We use summing point as one element, and to this summing point I'm giving some a which has to be multiplied by x. As you can see, a into x here. So this has to be given as plus, and there is something else like b into u. So you have a b matrix and also you have u here. So this is also given and this is a plus. So if you add these two, because u is the input, I have written it here. So u into b into u plus a into x will be give me x dash, but I want to get x from that, so I'll use an integrator. You can write 1 by s or integral, so I'll get an x. So this way you can connect this here. Ramchandra Kumar, good evening, welcome to Unacademy. So from here you also, in the output you have a summing point. This is y and x is multiplied by c, so I'll multiply this by c and give it to this summing point and plus then you can see d into u. You have u here, so take off point and you have a d, and this is given to this summing point. So this represents the state diagram. And always remember, at the output of integrator, you can represent integrator with this symbol with integral sign like this, or you can also take a block and write it as integral like this, right? So the output of integrator must be, if you say this is the output of integrator, it must be a state variable. It must be a state variable. Good evening, Praveen. So this is state diagram. So because it's a quick revision, we are just getting into a very short. Then we will have what is solution of state equation. So if you find the solution of a state equation is x dash of t is equal to a into x of t plus b into u of t, time dependent, time varying. Now if you apply differential equation or Laplace transform method, you can directly write it as s into x of s minus x of 0 is equal to a into x of s plus b into u of s. Right. Solution is x of t. So first I would like to separate x of s. So s into x of s minus a into x of s is equal to x of 0 plus b into u of s. What have I done here? Apply LT, Laplace transform. So this can give you, if you just take x of s common out, this is s minus a. To make it a matrix, I'm multiplying it by I. So x of 0 plus b into u of 0. So finally you can write x of s is equal to si minus a inverse into x of 0 plus si minus a inverse into b into u of s. So if you want to find x of t, apply inverse Laplace transform. This will give you x of t is equal to Laplace inverse of si minus a inverse into x of 0 plus Laplace inverse of si minus a inverse into b into u of s. So we'll call this as the first term. We'll call this as first term and second term, let's say. So first term is called as 0. You'll get it when the input is 0, 0 input response, or simply you'll call it as ZIR. And the second term is called as when the state is made 0, considered 0, 0 state response, or we'll denote it as ZSR. Now can we write from this what is ZIR is equal to? It is Laplace inverse of Si minus A inverse into, either you can write x of 0 inside or outside. Similarly, ZSR is equal to Laplace inverse of Si minus A inverse into B into U of S. Here B is a matrix, U of S is the input. Shiva Kumar, good evening. So these are the expressions for ZIR and ZSR. Right? So if you are so this is solution of state equation. Right? Now what is the next topic that we have? One is state diagram is completed, state model is complete, state diagram is completed, solution of state equation is also done. Now let's see transfer function of state model and state transition matrix. Now you want to find the transfer function. Transfer function. So what is transfer function? If you consider a system, its input is u of s, output is y of s. So the transfer function t of s can be written as y of s by u of s. Now if you want to find this, you can take two equations. State equation, x of t is equal to a into x dash is equal to a into x plus b into u, and y is equal to c into x plus d into u. And because we are finding transfer function, we'll assume the initial conditions to be 0. So this is s into x of s minus a into x of s is equal to, you can just take this left side and apply Laplace transform, b into u of s. So this is x of s is equal to, you can write the same way that we have written previously, si minus a inverse into b into u of s. So substitute this x of s in this equation output. Y of s is equal to, apply Laplace transform, c into x of s plus d into u of s. So we have y of s is equal to c into x of s plus d into u of s. Just consider this equation x of s here. X of s is si minus a inverse into b into u of s plus t into u of s. So can I write this as y of s is equal to, taking common u of s, c into si minus a inverse into b plus d into u of s. So what is the transfer function that you get? T of s is equal to y of s by u of s is equal to c into si minus a inverse b plus d. So this is the transfer function. Right? Now we'll write state transition matrix directly. It is state transition matrix. It has some properties and it is represented by phi of t. So when you are solving this when you are finding the solution of state model, you'll get this phi of t is equal to e power at is equal to Laplace inverse of si minus a inverse into, yeah, this is phi of t. And it also has some properties that you need to remember. One is phi of 0 is equal to e power a into t is 0, so that is identity matrix. Phi of t1 plus t2, if you write it, it is phi of t1 into phi of t2. If you just calculate, you'll get it. Similarly, phi of t, if you are writing phi of minus t, it is e power minus at, or you can write it as e power at whole power minus 1, or phi of t whole power minus 1, or you can also write it as phi of phi inverse of t. So these are some of the properties that you have. You have many more that you can read. Now these are the things that we have written. Now let's write the summary. So first point is state model. What is the state model? X dash is equal to a into x plus b into u, y is equal to c into x plus d into u. Second, state diagram, we can't draw it right now here, so what I'll do is I'll take up solution. In that first one I'll write is ZIR, then I'll write it is, then I'll write ZSR. ZIR is Laplace inverse of Si minus A inverse into x of 0, and this is Laplace inverse of Si minus A inverse into B into U of S. Then I'll write the transfer function. So the transfer function from state model is written as T of S is equal to y of s by u of s is equal to c into si minus a inverse b plus d. Now the fourth one that I want to write is state transition matrix. State transition matrix. So state transition matrix can be written as phi of t is equal to e power at is equal to Laplace inverse of si minus a inverse. So with this idea of part 1, this is a part 1, I can say. I'm just taking this as part 1 of unit 5. From this, we'll try to check some university question papers and try its solutions. So let's take one question paper that I have with me. The question says that, question is something like this. Consider the matrix. Consider the matrix. The matrix is given as A is equal to 0, 1, minus 2, minus 3. Compute e power at. Compute e power at. And we have seen what is e power at. It is phi of t. So let's say, so this is a question. We'll try to write its solution. What is the solution? This is one question that is asked in your question paper. So we know phi of t is equal to e power at is equal to Laplace inverse of Si minus A inverse. And what is this? We call it as state transition matrix. Right? So let's try to write it. So if you want to find phi of t or e power at, if he is asking you phi of t or e power at, that means it is Laplace inverse of Si minus A inverse. So first let us try to find, we are given A already, 0, 1, minus 2, minus 3. So we'll have to find Si minus A. So S into I is 1, 0, 0, 1, minus A is 0, 1, minus 2, minus 3. Why did I take it as 2 by 2 matrix? Because A is a 2 by 2 matrix. So this will be, if you multiply S inside, S 0, 0, S minus 0, 1, minus 2, minus 3. Further, if you simplify, S minus 0 is S, 0 minus 1 is minus 1, 0 minus of minus 2 plus 2, S plus 3. So this is Si minus A. Now let us try to find Si minus A inverse. But we need what? Si minus A inverse. So Si minus A inverse. So I'll just take a matrix A which has A, B, C and D. Then its A inverse would be 1 by AD minus BC D minus B minus C A. This you already know. You are very much familiar with that. So 1 by AD S into S plus 3 minus BC minus 1 into, so that is plus 2. D, what is D? It is S plus 3. You can see this is A, this is B, this is C and this is D, right? So D is S plus 3 minus B is 1. This minus 1 will become plus 1. Minus C is minus 2. A, what do you have? A in place of A, you have an S. So you can write Si minus A inverse is equal to 1 by S square plus 3S plus 2 of S plus 3 1 minus 2S. If you have any doubts, you can also ask me, or if I'm doing any mistake also, you can just check and tell me. That is, I'm just taking this term inside, S square plus 3S plus 2 1 by S square plus 3S plus 2 1 by, sorry, minus 2 by S square plus 3S plus 2 S by S square plus 3S plus 2. So this is the matrix Si minus A inverse. But we need to apply Laplace inverse also to that. So let's try to apply it. So what is e power phi of t? It is e power at is equal to Laplace inverse of Si minus A inverse. That is Laplace inverse of this matrix S plus 3 by S square plus 3S plus 2 1 by S square plus 3S plus 2 minus 2 by S square plus 3S plus 2 S by S square plus 3S plus 2. So you need to apply this Laplace transform inside. That will be Laplace inverse of each and every term. S plus 3 by S square plus 3S plus 2. L inverse of 1 by S square plus 3S plus 2. And Laplace inverse of minus 2 by S square plus 3S plus 2. Laplace inverse of S by S square plus 3S plus 2. Now we'll find these Laplace inverse individually, then I'll write the matrix, total matrix here once again. Once I get all the inverse Laplace transform of this, then I'll write e power at is equal to. So let's try to find that. The first one, Laplace inverse of S plus 3 by S square plus 3S plus 2. First you need to write this S square plus 3S plus 2 as factors. So can I write it as S square plus S plus 2S plus 2? Further you can take common S in this. So s plus 1 and 2, if you take common, it is s plus 1. So this is s plus 1 into s plus 2. Just multiply this, whether see s square plus 2s plus s plus 2. So this is s square plus 3s plus 2, satisfied. So this is satisfying. So these are the factors. So can I write this as Laplace inverse of s plus 3 by s plus 1 into s plus 2? Yes, you can write it. So how do you find that? So Laplace inverse of s plus 3 by s plus 1 into s plus 2. So for that you need to first partial fractions, apply partial fractions to this. So s plus 3 by s plus 1 into s plus 2 can be written as a by s plus 1 plus b by s plus 2. So take the LCM and write as plus 2a plus bs plus b, and take common s, it is a plus b plus 2a plus b. So the term this side is s plus 3. Now compare s terms on both sides. A plus b is equal to 1. Compare constants. 2a plus b is equal to 3. Subtract them. Minus minus minus, this will be cancelled. Minus a is equal to minus 2. So a is equal to 2. Is that correct? Can someone please let me know if a is 2? Right? So a value is 2. Now let's try to find b value. A plus b is equal to 1. When a is 2, 2 plus b is equal to 1. B is equal to minus 1. So b value is equal to minus 1. So I'll write this as Laplace inverse of s plus 3 by s plus 2 into s plus 1 is equal to Laplace inverse of 2 by s plus 1. Yes, okay Sanjana. 2 by s plus 1 minus 1 by s plus 2. So can I split this? Laplace inverse of 2 by s plus 1 minus Laplace inverse of 1 by s plus 2. Yes. So you can write this as, what is Laplace of e power at 1 by s minus a. So what is Laplace inverse of 1 by s minus a? It is e power at. If this is plus, this is minus. So you can take common to Laplace inverse of 1 by s plus 1 minus Laplace inverse of 1 by s plus 2. So what is the Laplace inverse? 2 into e power minus t, 1 by s plus 1. In place of a you have 1 minus e power minus 2t. So this is the Laplace transform of the first term. This is the Laplace inverse Laplace transform of first element, s square plus 3s plus 2. That we have written it like this, right? So this is Laplace inverse. So let's write this 2 into e power minus t, yeah, this value, Laplace inverse of this term, 2 into e power minus t minus e power minus 2t. So this is the first value that we got. Now let's take 1 by s square plus 3s plus 2, Laplace inverse. Now let's take the other value, Laplace inverse of 1 by s square plus 3s plus 2. So for this also you need to first find partial fractions. 1 by s square plus 3s plus 2 can be written as 1 by s plus 1 into s plus 2. So you can write this as a by s plus 1 plus b by s plus 2. So that is 1 by s plus 1 into s plus 2 can be written as like this. So you can write 1 is equal to as plus 2a plus bs plus b. Take common s, you'll get a plus b, and this is 2a plus b is equal to 1. Now compare the coefficients. Now compare coefficients on both sides to this. What do you get? A plus b is equal to 0. You do not have any s term this side. So, and 2a plus b is equal to 1. So can I write a is equal to minus b? Substitute in this. 2 into minus b plus b is equal to 1. Minus b is equal to 1. Minus 2b plus b minus b is equal to 1. So b is equal to minus 1. If b is equal to minus 1, what is a is equal to 1? So b value is minus 1 and a value is 1. So let's try to apply inverse Laplace. Laplace inverse of 1 by s square plus 3s plus 2 is equal to Laplace inverse of 1 by s plus 1 minus 1 by s plus 2. Split this inverse Laplace. Laplace inverse of 1 by s plus 1 minus Laplace inverse of 1 by s plus 2. What do you get here? Laplace inverse e power minus t minus e power minus 2t. So this is the Laplace inverse of 1 by s square plus 3s plus 2, the second term. So write the second term e power minus t minus e power minus 2t. So e power minus t minus e power minus 2t. Yes. Now let's take the third term. Minus 2 by s square plus 3s plus 2. Minus 2 by s square plus 3s plus 2. So Laplace inverse of minus 2 by s square plus 3s plus 2. You can simply write it as minus 2 outside and write the same thing, but I'll just do that in a different way also. So minus 2 by s square plus 3s plus 2 can be written as minus 2 by s plus 1 into s plus 2. So you can write it as a by s plus 1 plus b by s plus 2 is equal to minus 2. Minus 2 by s plus 1 into s plus 2. So to this you can write minus 2 is equal to as plus 2a plus bs plus b. Take common s, you get a plus b plus 2a plus b is equal to minus 2. Now compare the coefficients. Comparing coefficients on both sides. So you do not have any s term here. So a plus b, this is s term coefficient. A plus b is equal to 0 and 2a plus b is equal to minus 2. So you can write a is equal to minus b. So 2 minus b plus b is equal to minus 2. So minus b is equal to minus 2. B is equal to 2. If b is equal to 2, a is equal to minus 2. So can I write it as Laplace inverse of minus 2 by s square plus 3s plus 2 can be written as Laplace inverse of minus 2 by s plus 1 plus 2 by s plus 2. So if you can split the Laplace inverse of minus 2 by s plus 1 plus Laplace inverse of 2 by s plus 2. Further you can write minus 2 of Laplace inverse of 1 by s plus 1 plus 2 of Laplace inverse of 1 by s plus 2. So you can just write this down, minus 2 into e power minus t plus 2 into e power minus 2t. E power minus 2t. So this is the inverse Laplace of minus 2 by s square plus 3s plus 2. Clear? So let's write that 2 into e power minus t. So this is 2 into e power minus t minus 2 into plus 2 into e power minus 2t. Now let's write the last term s by s square plus 3s plus 2. Can someone tell me what is the value of that? Laplace inverse of s by s square plus 3s plus 2 is equal to, first just split this s by s plus 1 into s plus 2. So you can write it as a by s plus 1 by b by s plus 2. So this is as plus 2a plus bs plus b is equal to s. So s is equal to s of a plus b plus 2a plus b. Compare coefficients on both sides. S coefficient is 1 here, so we'll get a plus b is equal to 1. Yeah, a is equal to minus 1 and b is equal to plus 2. Very good. Next 2a plus, very good Meghana, 2a plus b is equal to 0. So 2a is equal to minus b, or b is equal to minus 2a. You can write it that way. B is equal to minus 2a. So a plus minus 2a is equal to 1. A minus 2a is equal to 1. A is equal to minus 1. If a is equal to minus 1, from this you will get b is equal to minus 2 into minus 1, that is 2. So b is plus 2, a is minus 1. That's correct. So for that, Laplace inverse of s by s cube, sorry, s square plus 3s plus 2 can be written as Laplace inverse of minus 1 by s plus 1 plus 2 by s plus 2. So split this, Laplace inverse of minus 1 by s plus 1 plus Laplace inverse of 2 by s plus 2. Furthermore, you can write this minus 1 into Laplace inverse of 1 by s plus 1 plus 2 into Laplace inverse of 1 by s plus 2. Then you can write it down as minus 1 into e power minus t plus 2 into e power minus 2t. So this is the Laplace inverse transform of s by s square plus 3s plus 2. Right? Now write this value minus e power minus t plus 2 e power, this way, minus e power minus t plus 2 e power minus 2t. So this is the final answer. Phi of t is equal to e power at. This has to be done. Remember, this has to be found. Although it looks very easy, but it's very lengthy. That's the only thing. You need to know Laplace transform and inverse Laplace transform. So this will be the state transition matrix that is asked in the question paper. State, although he will not give you sometimes directly state transition matrix, remember, if he is giving you as phi of t or e power at or Laplace inverse Laplace transform of si minus a inverse, you can directly say that it is a problem on state transition matrix. Even though you are asked e power at, it is state transition matrix, or phi of t, it is state transition matrix. So this is one question. Let's see one more question. See, the questions are given. This we have already done. I'll just write the questions. Previously also there is one question. See, there was a question. So the solution to all this will be same. Derive the state transition matrix using Laplace transform method. This you need to do that. The same question, there is some question like obtain the solution of system whose state model is given by x dash is equal to a into x of t plus b into u of t and x of 0 minus x naught. X of 0 is equal to minus x naught. So this is something given. Sometimes he'll not give you this as x dash, he'll just bold it. He'll just bold it. That means it is a x dash. Remember that. So this question also we have done already. We have just solved it, but only thing the difference is this one. This question also I have derived, and there is one more question, and also the continuation of this is and hence find state transition matrix. That's the continuation of this question. There is one more question. Discuss the significance of, this is one. Discuss the significance, advantages that I told you. Significance of state space analysis. These are all the long answer questions. There is one more question like, what is state transition matrix? What is state transition matrix? And obtain its expression and derive its expression. And derive its expression. This is one. And one more question. Write the advantages of, these are all the theoretical questions that you can learn from the theory part that I told you. Write the advantage. You can also refer my lectures, long full-fledged lectures on control systems course. This is a quick revision playlist. You also have one more. What are the advantages of state space analysis over transfer function models? Transfer function models. This is one question. There is also some question like the same question. What is the advantage of state space approach? What are the advantages of state space approach? Then one more question you can see here. This question is, derive the solution of homogeneous state space equation. Derive the solution of homogeneous state space equation. What does this mean actually? Can you tell me what does this mean? This means that you need to take homogeneous input as 0, free response, then that is nothing but ZIR. He is asking you to find 0 input response. He is asking you to derive 0 input response. Sometimes he will not specify ZIR, but he will give you something like this. You need to be careful and write the answer properly. And let's see. This is a problem. We'll solve that problem. Do not worry. Derive STM using Laplace transform method, and that's one question. State and prove the properties of STM. That's one more question. See, there is another question on STM, so I don't want to solve another question. I'll just write the question, but you can just solve the question. Find out, the question is, find out state transition matrix of the following system. The system is x of t is equal to 0 1 0 minus 3 into x of t. He just gave it as capital X, so it indicates z x dash, plus 1 0 of u of t. So you can solve this question, I guess. And there are some questions on controllability, observability, which I will discuss in the next session. Yes, so let's try to do one more question. We have done a question on state transition matrix, so now we'll try to do one question on response. Let's take one question. Yeah, for the same question, that we have written previously, he also gave us to find ZIR, ZSR. So consider the matrix. So consider the matrix A is equal to 0, 1, minus 2, minus 3. Compute ZIR and ZSR. So you need to know the solution for this. For that you need to know ZIR. What is ZIR is equal to Laplace inverse of Si minus A inverse into x of 0, right? So because x of 0 is not given, you can take x of 0 as 1. He may also give you x of 0 is equal to 0 comma 1, something like this, right? ZSR is equal to Laplace inverse of Si minus A inverse into B into U of S. So in order to compute this U of S, you need to know the ZSR, you need to know U of S. So U of S can be considered as 1 by S, considering U of T as step response. So this question is an incomplete question that is given. So there are two things that are missing in this part and this part. So let's consider one more question which has everything, a proper question, so that, see, there is one question that I want to discuss. Then we'll move on to that response ZIR ZSR. The question says that derive the state model, derive the state model for the system described by differential equation. This topic we did not discuss in this, but you can find the same lecture in control systems course that I have discussed in phase variable form, right? So this phase variable form is the same that we already do generally. This is y triple dash plus 4y double dash plus 5y dash plus 2y is equal to 2u double dash plus 6u dash plus 5 into u. So this is the question. So how you should do this is, you need to consider, so first one, because this is something like d cube y by dt cube plus 4 d square y by dt square plus 5 dy by dt plus 2 into y is equal to 2 d square u by dt square plus 6 du by dt plus 5 into u. I think you may not be able to see this. Now you can see this. This is the differential equation we have. We need to consider in phase variable form. What we do is, we'll consider the first, how many state variables does this have, that you need to write, right? Number of state variables is equal to, how many number of state variables you have? 3 state variables. What are they? You can say x1, x2, x3. This is a state vector x. So what will be x dash is equal to x1 dash, x2 dash and x3 dash. So first let's try to write that matrix. X dash is equal to a into x plus b into u. Y is equal to c into x plus d into u. Notice x dash, it is x1, x2, x3 dash is equal to a matrix into x1, x2, x3. This is not the derivative, plus b into, what is u? U has, how many u have? D square, u by dt square, right? So you can write u here, and y is equal to c into x. X is x1, x2, x3 plus d into u. Right? Now what is the size of these matrices? That's more important. What is the size of this? 3 by 1. So this is also 3 by 1. So here it is b into u. Now What is the size of y? 1 by 1. What is the size of this? 3 by 1. What is the size of this? 1 by 1. Now you can define the size of a, b, c and d. After this, what you need to do is you need to consider y is equal to x1, or the first state variable is considered or taken as output, and the rest of the state variables, the other state variables will be derivative of first state variable. So this is phase variable method. Like you can take, this is x1, so you can write x1 is equal to y. What is x2 is equal to x1 dash, that is dy by dt. What is x3 is x2 dash, that is d square y by dt square. Right, so you can get x1 dash, you get the equations from this. If you write, you know, x1 dash is equal to x2, x2 dash is equal to x3, but you also need to have an expression for x3 in terms of x1, x2, x3 and u. Right, so you just need to substitute this in this equation and find the value of x3 dash, then determine x1 dash, x2 dash, x3 dash in terms of x1, x2, x3 and u, and substitute this in this state model. This is the state equation and this is the output equation. Right, so this is how you'll do it, and let's try to do one problem on ZIR and ZSR. I'll just tell you how do you do that. Let's say the question given is find ZIR and ZSR given, and ZSR for unit step input. ZSR for unit step input given x dash is equal to 0, 1, minus 3, minus 1, x plus 0, 1 into u, and x of 0 is equal to 0 and 1. So what is that expression that you know already? You know ZIR is equal to Laplace inverse of SI minus A inverse into x of 0, or you can also write it as x of 0 inside. Then ZSR is equal to Laplace inverse of SI minus A inverse into P into U of S. So first to calculate ZIR, you need to first calculate SI minus A, then determine the value of SI minus A inverse, then determine the value of Laplace inverse of SI minus A inverse, then multiply this SI minus A inverse with x of 0. Right, this is ZIR, and in order to calculate ZSR, first find SI minus A inverse, or first find SI minus A, then determine SI minus A inverse, then multiply SI minus A inverse into B into U of S. Then apply Laplace inverse to this whole term, SI minus A inverse into B into U of S. You may not be able to see this, I'll just move it. Yeah, you just have to follow this. So this will be your ZSR and this is your ZIR. Hope you were able to understand this. and if you still have any doubts you can ask me. So today we have discussed part A of chapter 5 as state model, state diagram, state transition matrix, solution, that is ZIR and ZSR, fifth, transfer function. You may also be asked a question on this transfer function, although I did not find any question on this. So I'll just move on the slides once again from starting. If you have any doubts you can ask me. Yeah, we have started here. Then this is state diagram, solution of state equation. ZIR, ZSR, this is ZIR, ZSR, this is transfer function. So we have considered this matrix and found e power 80. Just looking for some question. Till then you just move on this. Si minus A inverse. Then we try to find the phi of t, and phi of t is found something like this. I'll just show you. Yeah, these are things that we have used to find phi of t. Inverse Laplace transform. So then I told you how do you find ZIR, ZSR for given unit step input. This is the method. So as a part of chapter 5, we have discussed state model, state diagram, state transition matrix, solution and transfer function. So this is chapter 5 part A. Then as I told you, we have number one study channels on Unacademy. Do like this video, share this video and subscribe to Unacademy. Use my code YSK10 to get the maximum discount and subscribe to Unacademy Semester Exams. You can also join us on Telegram for more upcoming videos. So let's crack GATE and ESE with India's largest learning platform, Unacademy. Thank you.